Good afternoon, everyone. Welcome to our new tutorial. Today we're going to discuss about factor theorem. So let's start. Again, before anything else, let's try to divide this polynomial by this polynomial. As you can see, the divisor is in a form of x minus c, or linear binomial. To divide that, let's divide the first term with the first term of the divisor. So that is 4x cubed divided by x. So we have 4x squared. Now let's multiply 4x squared to x minus 2. 4x squared times x is 4x cubed. Then 4x squared times negative 2, that would be negative 8x squared. Now let's subtract this by changing the sign and proceed to addition. So we cancel this out. And this one will have 5x squared. Then we need to bring down 8x. So we have this as our new term, or our new term to be divided. So 5x squared divided by x, that would be 5x. Then 5x, let's multiply 5x to x minus 2. That would be 5x squared minus 10, because it is negative. Now let's subtract them by changing the sign and proceed to addition. So we cancel this out, and this one will become positive 2. Then let's bring down 4. Now let's divide 2x by x. The answer is 2. Then let's multiply 2 to x plus 2. And we'll get an answer of 2x plus 4. Again, let's subtract them by changing the sign and proceed to addition. And for this, we'll be canceling all of the terms, and we have a remainder of 0. Now, if we divide a certain polynomial by another polynomial, and if the remainder of that will become 0, therefore, this polynomial is a factor of this polynomial. For example, if you divide 15 divided by 3, the answer is 5. Then therefore, 3 is a factor of 15 because there's no remainder on the quotient. But if we divide 21 divided by 2, the answer is 10 with remainder 1. So 2 is not a factor of 21 because it has a remainder. So that's the basic concept of factors of a number. Same as with the factors of a polynomial. Now let's go to the algorithm of the division algorithm, where d of x is our divisor and our q of x is our quotient and r is our remainder. Since that there is no remainder in here, 0, we'll just focus on this. So these two are factors of this, which is this. Now using the knowledge that we have on our remainder theorem, we could substitute 2 to the polynomial to this one, and we'll get an answer of 0. Now let's try that on the polynomial itself. Let's try to substitute 2 here. Now again, 2 comes from here, the value of RC. So x minus c, so R2 is a value of RC. So if we substitute 2, we can get a value of 0. And that makes this one a remainder of this, a factor of this. So the factor theorem will help us determine if x minus c, or a divisor in a form of x minus c, is a factor of polynomial in x. So factor theorem states that if x minus c is a factor of p of polynomial x, then p of c is equal to 0. And its converse is if p of c is equal to 0, then x minus c is a factor of polynomial x. Now let's try to answer questions about this. Now let's verify if this is a factor of this. Now we need to consider this as a divisor for this polynomial. If there is no remainder, then therefore this is a factor of this. Now let's consider this as a divisor, so let's find the value of c. So to find the value of c, you could just compare the divisor with x plus c and encircle the value of c. In this case, the value of c is 2. But if you're having trouble with that, just equate x minus c to 0 and find the value of x, which is equal to the value of c. So it's safe to say that we can equate x minus 2 to 0 and find the value of x, which is 2, because 2 is also equals to c, because c is equal to x. So the value of our c is 2. So now let's substitute 2 to the value of x. So in this case, we have this. So this will become, and this one. So if we go to evaluate it, 2 raised to 3 is 8. 2 raised to 2 is 4 minus 4. Then 2 times 2 is negative 4 plus 6. So if we going to evaluate that, P of 2 is equal to 6. Now, remember, if P of 2 is equal to 0, then therefore it is a remainder. It is a factor. But since 2 is not equal to 0, P of 2 is not equal to 0, therefore, x minus 2 is not a factor of polynomial x cubed minus x2 minus 2x plus 6. It is not a factor. Now, example number 2. Let's check if x minus 1 is a factor of this. All we have to do is to divide this by this and see if the remainder is equal to 0 or not. To find that, let's check for the value of c, which is 1, or just equate x minus 1 to 0 and find the value of x, because the value of x will be equal to the value of c. Now let's try to substitute 1 on our x. So we have this 1 cubed is 1, 1 squared is 1, then times 1, and we have this. So 1 plus 4 minus 6 plus 1 is equal to 0. If it is equal to 0, therefore, x minus 1 is a factor of this. Let's go to example number 3. Use the factor theorem that to show that 2x minus 1 is a factor of this polynomial. Again, let's find the c first. We have our c as our 1 half. Or we could just equate it into 0, find the value of x, and if the value of x is negative, is 1 half. Now let's substitute 1 half on our x, and we have this. Now to simplify this, we just have to multiply 2 to 1, that is 2 over 8. Now the simplest form of 2 over 8 is 1/4. Now 7 times 1 is 7, that is 7 over 4. Then 6 times 1 is 6 over 2. 6 over 2 is 3. That's why we have this kind of equation. Now let's combine all the things that we can combine. 1 plus 7 is 8. Then 3 minus 5 is negative. So we have 8 over 4 minus 2. 8 over 4 is equal to 2 minus 2. And that gives us an answer of 0. Since p of 1 half is equal to 0, therefore, 2x minus 1 is a factor of 2x cubed plus 7x squared plus 6x minus 5. Now let's push the example much more into an average kind of question. Now let's find the value of k so that this will become a factor of this. So this polynomial expression has a missing term or a missing number here, which corresponds with the letter k. So we need to find the value of k in so that this will become a factor of it. So if this will become a factor of it, therefore this is divisible by this. So let's try to compute for the value of c, or just equate x minus 3 to 0, and we get 3 as a value of our c. Now, if we substitute the value of, if we substitute 3 to the value of x, if it is a factor, then this polynomial should equal to 0. Now, now let's see if that is the case. Let's substitute all the x 3 to all the x's, and we get this as our equation. P of 3 is equal to 33 minus 3k. We cannot simplify it further. We cannot simplify it further because there's no there, there's no like terms that we could combine. Um, to further find the value of k, let's equate this into 0 because we assume that x minus 3 is a factor of the polynomial. So we have 0 is equal to 33 minus 3k. Let's subtract 33 on both sides. So now let's divide both sides by negative 3. Therefore, the value of k is equal to 11. So now let's go to our last example. Find the value of a and b so that x minus 3 and x plus 1 are factors of polynomial x cubed plus ax squared plus bx. Let's put some dot here. So we need to find the value of a and b so that these two will become a factor of it. Now imagine that we're going to divide this polynomial with this divisor. So all we have to do is to find the c for that for each divisor. So now let's try to substitute this to this polynomial. And we know that, and after that, we will equate that into 0 because we know that if this is a factor of this polynomial, then the answer for this should be equal to 0. So let's rewrite the polynomial. After rewriting, let's substitute 3. Then let's evaluate, and let's have this, and let's equate it into 0. Now, to further simplify, we need to divide all sides into 3 because all of them is divisible by 3. So we have 0 is equal to 3a plus b plus 10. I just divided all of them into 3. 0 divided by 3 is 0. 9 divided by 3 is 3a. 3b divided by 3 is b. Then 30 divided by 3 is 10. That's why we have this. Now let's go to the other one. If x plus 1 is a factor of it, then if we substitute negative 1 to x, then the answer should be equal to 0. So after we further simplify it, we can have this equation. We should equate it into 0. Now we have a system of equation. At first, I will like to solve for the value of a first using this equation. Or you could just add it if you want, but I will pursue on this one. So I will get 0 is equal to a minus b plus 2. Then I will solve for the value of a by adding b and subtracting 2 on both sides. Therefore, the value of a is b minus 2. Now after that, I have a value of a. I will use the first equation and substitute the value of a that I have. See here, this a. I just substitute this to this. So I have this. Now in substituting uh, variables or substituting, it is a nice habit to put the thing that you're going to substitute inside a parenthesis. Now let's multiply 3 to b minus x. So 3 multiplied by b is 3b, and 3 multiplied by negative 2 is negative 6. Now let's combine like terms. 3b combined with b is equal to 4b, and negative 6 plus 10, positive 4. Now let's transpose the 4 on the other side, and we have negative 4 is equal. Now let's divide both sides by 4, and we can see that our b is equal to negative 1. If we have RB as our negative 1, let's use this equation to find A. So we have A is equal to B minus 2. Substitute 1 to B, and that is negative 1 minus 2. And our A is equal to negative. And our these are the value of A and B. A is negative 3 and B is negative. So thank you everyone for your time to listening in this tutorial. Hope that you learned something. and I hope that it will help you in your math subject. That's all. Goodbye.